All right, then we move on to the next program. And the next program is, just let me start the presentation. Biomedical engineering. Again, a program which is offered by a quite high number of faculties here in Wien. And we are honored that
I'm honored.
Assistant Professor Andreas Körner is here today. Some of you might know him because he's doing the introduction courses in mathematics. Yeah.
What to say?
Well known for that. Yeah. But what I learned from preparing for this event here today, you also studied electrical engineering.
This is correct. Yeah. The dark bag.
2 degrees. Yeah. 2 degrees as engineer, and he has a doctorate. Tell us now about biomedical engineering. This is also a program which was offered right from the beginning in English, and he's replacing the Dean of Academic Affairs here. He is not available because as Bettina Mihaly-Schneider, he had to go to the Deans of Academic Affairs meeting today, and therefore Andreas Körner is here, and he is heavily involved in this master curriculum as well. So.
Thank you very much. As Peter already said, I'm substituting the Dean of Academic Affairs, but I'm also active in the Study Commission for Biomedical Engineering. As already addressed, Biomedical Engineering was from the beginning an English-speaking master curriculum, and all faculties of our university is involved except the Architecture and Urban Planning faculty, for obvious reasons, I would say. And I would like to start a bit with a picture. So the presentation is made by Eugen, but let's say I took it over and prepared it in the way how I would give it. Let's say in the end of the 90s, somehow we have the first trials to specify what biomedical engineering can be or should be, or what possibilities you have involved in biomedical engineering, and somehow one characterization is from the mid-90s, let's say, the source you see in the bottom of the slide, and somehow you can sum it up with a certain field which is involving a biological aspect in terms of having a patient present, but as well certain doctors treating this patient. And if you think about you're young enough that you have no medical problems, at least I hope so. If you go for regular tests in the medical department, doing a blood analysis or whatever, thinking about these simple aspects in doing a blood analysis or having a radiation scanning or something like this, if you list how many engineering and natural science disciplines are involved in this, then you come up with, let's say, at least 7, because our university has 7 faculties involved in this. What is the special setup here is that everything is oriented to biology or medicine in terms of treatment, diagnosis, and aspects which are related to this. So what I would like to present, or what Eugen wants me to present today, is somehow we talk about the qualification profile, we talk a bit about the model structure, and some slides he insisted to have in that we have as well some fun in the master studies. I will try to do my best to transmit this fun as well to you. About the qualification profile, so somehow it's summed up here in German and English. The English is a bit less than the German. I'm sorry for this, but nevertheless, the key components are included. Are somehow summed up with this basics and advanced research. You have some development of biomaterials, sensor, instrumentation methods, and something related. You have a lot of modeling involved. This is the reason why I am included in this master program. Modeling and simulation somehow is my background from the mathematics department. Modeling in biology or modeling in medicine is quite thankful, because I'm always arguing that these are 2 disciplines which have no exact sciences present. So mathematics can enter and conquer this field, and we did quite successfully the last years. Then, of course, you have some operational use of technical systems, and somehow consulting is as well a certain aspect which is included in the qualification profile. By definition, it's interdisciplinary. If you have a certain mathematical model, this is not helping in any way if you have no data available, if you don't have any functional understanding of a certain process, of a certain happening in the field. So let's say most of the projects are interdisciplinary oriented, and the study is, let's say, picturing this out in a way. We have standardized 4 different specializations in the master studies. The first specialization is biomaterials and biomechanics, maybe a certain overlap to material science, I'm pretty sure, but of course oriented to the biomedical application approach. Second specialization is biomedical signals and instrumentation, and I'm always surprised, but let's say this is the branch where technical chemistry is somehow much involved. These biomedical signals and instrumentation somehow is shared between chemists and electrical engineering somehow. So they are quite active, the colleagues from this faculty. Then mathematical and computational biology, a second to announce this. It's not only mathematics involved here. As you can see, the example what is illustrated here is, for example, a certain 3D mesh of a bone. So you can see that the part of the bone is missing, and somehow mathematical and computational methods you can use to simulate which structure is needed to replace this. And the last part, medical physics and imaging. So everything what is falling in this regard is, let's say, nuclear medicine somehow, imaging techniques of different kinds. Let's say involved are the technical physics department or faculty and informatics faculty is quite present in this specialization. But as I said in the beginning, it's not that this is clustered with solid borders. This is somehow, let's say, only the try to specify these 4 parts here. Of course, what is additionally required in the qualification profile is somehow the professional and methodological knowledge. Somehow, quite basics are taught in the first 2 semesters, I would say. But you have as well some experimental courses, laboratory work, seminars, practical work, whatever. Just to make clear once more, interdisciplinarity is quite a topic. We have some collaborations with medical university. Since one professor from chemistry is now the vice rector for research at the veterinary medical university, I'm pretty sure that even there will come some interdisciplinary projects. But nevertheless, somehow it's quite established, this relation to the medical universities, especially in Vienna, being that we are that close. And social competences, of course, especially in the field of biomedical engineering, where ethics is a certain topic, you should bring as well in this study. What did I do? But it's green still.
Okay.
So let's see. Okay, let's come to the model structure. I don't know what I did, but you know, when a mathematician is taking care on engineering. The model structure of the master study is organized in that way that we have a certain module which is called life science module. This is basics of biology and basics of physiology. This is mandatory for all students. Let's say the entrance card. Then we have fundamentals in biomedical engineering. This is the first possibility to orient yourself a bit in a certain direction. You see that you have to choose 4 out of 7. These 7 are listed here. So, for example, one which is related quite well with chemistry is the biochemistry module here. But, for example, another one is cell biology, which is, I would say, interdisciplinary between biophysics, chemistry, and related groups. But we offer as well a certain module which is called scientific computing. If you don't have a certain education in a programming language and in how to do computational modeling, this would help to come to a certain status that you can follow the courses which are offered in the specializations here. And somehow you see 4 out of 7 is somehow the idea behind that you don't need to know in the beginning in which direction you want to go. You can, let's say, enter in one field and see if it's the right one. And if it's not, you can change within the studies, of course. But 4 out of 7, in the end, you have to prove in terms of having the certificates. Then you come to the specializations. The specializations are 4 here. You see here the biomaterials, the signals and instrumentation. So especially here you see once more, it's the same category as we had slides before, the specializations of the qualifications of the students. Once more, the mathematical and computational biology, for example, is where we are offering our courses. And all of the specializations are organized in that way that first you enter in a certain basic module. Basic module means that you have courses listed what you have to participate. And afterwards you have the option to enter in the advances. And somehow the regulation see 15 ECTS plus 9 ECTS. This 15 ECTS needs to be from one of the specializations. And the 9 remaining you can invest as well in the same specialization. So if you're 100% sure this is the way I want to go, then you can invest it there. But if you're not sure and if you want to have a look to other specializations as well, the 9 ones are, let's say, investable in the 3 others as well. Then we have the diploma thesis, 30 SCDS. I guess we have no choice. It was the same in the material science before. But to have a certain program before entering directly in the diploma thesis, we offer this project work, what is more or less organized in that way. If you want to decide for a certain field and you plan to make the diploma thesis there, then you can have a project work before to enter in the field, to study a bit with literature, what is available there. And let's say this is the smoothing phase between the studies and entering in the diploma. And of course, we have the free elective and soft skills, but this is somehow according to the requirements from the curriculum design. There we are not free. It's the same as Paul explained in the last master studies. Last but not least, I would like to transmit, of course, as well fun in our master program. The Dean of Academic Affairs obviously imagined fun with this. So we are including our students in the project works quite, let's say, quite toughly. So students are working, let's say, as participants in different studies, but also as people which are organizing the studies. So for example, I don't know exactly what was happening here, but this is made in the hospital in the 22nd district, and people which are, let's say, the test animals and people which are doing or performing these studies were all students of biomedical engineering. So if you want to test your colleagues, this field is quite interesting. What it should transmit somehow is that we are applied somehow, right? So the project work is not only programming something on the computer and then handing it over and leaving it. No, it's necessary that you enter in a certain laboratory and test your program on certain devices and see if it's working or it's not working. Well, this was a short overview. I'm pretty sure that I'm in time. Perfect. So if you have any questions, of course, you can contact all of us, so either the dean or me. You can have a look to the web page of the students' representatives. Even in that way, maybe to add this, being that I have some minutes left, student representatives in our studies is let's say, a combination of representatives of more or less all faculties. So it means that if you have questions, especially regarding the biomedical engineering studies, just consult your own student representation. There is at least one person active as well in the study commission in BME. Well, then thank you very much. And I hope you had fun.
Yeah. Thank you very much also from my side, Andreas, for your nice presentation. Just to add this, in the beginning, this biomedical engineering master's curriculum was introduced as standalone master curriculum, which allowed other bachelor degrees to enter this master curriculum. As far as I know, there is a bachelor degree for biomedical engineering in development.
Yeah.
I don't know exactly when it will start, but I think
neither.
it will not be this autumn.
No, definitely.
And we don't know what will change when the bachelor degree in biomedical engineering is starting. So if you're interested in this area, now is the time to get into it.
But it will not meet you, the changes in the master program, because it means that, let's say, earliest possibility is winter term 2026. Maybe 7.
Yeah.
And then 3 years that these bachelor students are entering in master, so the master will not change within the next 3 years, I'm pretty
I
sure.
just wanted to mention that.
But of course, yeah. So if you have young siblings which want to go to biomedical engineering, thank you.
All right, thank you very much.